In this video, we will recreate geometry entirely inside VEX. The setup is pretty simple. We have our big face geometry and we connect it to the second input of our wrangle, and we run over the detail one time of this code, and we basically get the same geometry as inside here. We even get our UVs back, and we get also the groups of geometry. So it should be very fun exercise for us to know more about how geometry is created inside VEX, and just also how geometry is created just as a fundamental knowledge about the primitives and points and vertices inside any 3D package. So let's get on to it. Let's begin. For the setup, it's very simple. We have our test geometry. For this, I use the pig head, and I'm just going to connect it to the second input for our wrangle. So basically, we have a direct connection to our geometry, but we do not have any output for it. So let's try to get this geometry entirely from VEX and basically recreate it on this node as it would be as a first input. So let's get to it. So let me open it up. Let's start by creating a couple of variables. First of all, we will reference them one time, so we could just write it inside the one time we are actually going to reference them, or for the easier readability for the code, we can just create a variable. So let's call it prim count. That's going to be n primitives. So basically we're gonna get just how many primitives there are for our second input for our geometry. So we know there's 2816 primitives, so we have this number, and also we want to get how many points there are, so that will be basically the same. So we can copy it. It's going to be n points, and let's call it the point count. Alright, so now we have our two values. Basically we have got these two values and we're going to loop over them. So first of all, we want to recreate the points that there are on this geometry, since on these points we are going to actually create these polygons, but we do not want any overlapping points. We want to exactly that many points and exactly in that order. So let's do that. That will be pretty simple. So all we have to do is let's call it a for loop. Let's call it a current point. Actually, that would be a point count. And let's call it a variable as a cur point. I just copy this in y like that. So now we are looping over the 2789 times. And let's do this. Let's get the position of the points on our geometry. So it's going to be a vector. I'm just going to call it position, or pt pos, equals user point. So there's going to be one attribute is going to be position p, and point number is going to be our cur point. And now all we have to do is add point. And it's going to be, and now I want to write this point to our first input. So where currently it's empty, and we just feed our position for it, and that's it. So now let's actually start by looking at the, not the pt positions like that. Let's actually start looking at, so you see we have copied our points to our input, to our wrangle node. And what's important is that these points are exactly the same as these. So the point order has not changed. So this is very important for us when we are starting to actually create the vertices for every point. So because there's multiple vertices for every point. So that's that. Let's create another loop. So the next one is going to be, we're going to loop over our primitives. So let's get our primitive count. Let's put it inside here and cur prim. Copy it, paste inside y, and instead of y, like that. And now for every loop that we run over these current primitives of this geometry, we want to add a polygon. So let's use it, add poly, add prim, and that's going to be, so we want to add primitive to our actual geometry, and the type of it is going to be poly. So let's take a look at what actually how you see that now in our geometry spreadsheet, there's actually now some numberings as a primitive. So if I delete, I will copy and delete it, you'll see up and before this we only had points on it, so we didn't even have any primitives. But now that we have added primitives, now we have the same number of primitives, but for these primitives they do not have any vertices, so they do not look like polygons. So basically it doesn't know where to connect each other polygon to what vertices, so since we have not added any vertices. So for this function it's very simple. So let's take a look at actually the add prim vex function. So you can see that there's a bunch of ways we can do it, but we won't really do it in these. We're going to use it looping over. So, but for the type of it, you will see that we can use a poly type and polyline and a bunch of others, which I really don't use. But these two are very common in VEX. So the polygon is going to be the traditional polygon face, and the polyline is going to be just like your polylines in any other, like you can draw and all of that. So now we have our empty polygons. For us to understand how we are actually going to create these polygons, let's go to the simple box and let's take a look at the same concept only on a smaller scale. So open up a geometry spreadsheet and go to the vertices, and you will notice that there are a lot more vertices than we have actually primitives or points. That's because for every primitive there are multiple vertices. So if you select a primitive, let's say primitive number 0, you see there's going to be lighted up, there's going to be 4 values highlighted. So the numbering is pretty simple. So the first value is always going to be a primitive number. So if I select 1 or 0, it's a primitive. And then 0, 1, 2, 3 is going to be a vertices number inside this polygon. So since this is a 4-sided polygon, for every edge, there's going to be a 1 vertex. So since this is a quad, we have a 4 vertices for every point of this polygon. And if we had a 5, there would be 5 and all of that. So that's that. And since this point is actually shared with the multiple polygons, on this point there's going to be a multiple vertices. So let's select the point 5. You see, we will see that there are 3 values highlighted. So this means that this point is shared by 3 polygons, and that's true. And what's very cool that we can actually sort by point number. So you see, if I select 5, you see it's going to highlight all of the 5 points. You know that there's 5 polygons that are shared. So let's say I pick a poly split and split it in half like that. Let's select it again. You see now we have 4 values, because now we have 4 polygons for this one point, like that. Now let's go to the help file and let's use our prim points vex function, which is to return the list of points on a primitive. So this is exactly what we want. And for these points, we want to just loop over and add vertex for every point of it. So let's get onto it. So let's create an array. This is going to be an int array. Let's call it prim points. And let's square brackets for the array. Remember, let's get our prim points on geometry 1, and prim number is going to be a current primitive, like that. And now let's run over this array. So for array, it's always a for each. So we do not need an index, so we want just a value. So that's going to be int value. Let's call it a current point, and let's give it an array prim points, like that. And all we have to do is an add vertex. So add vertex function, it's very simple. We have to give it a geo handle to add to. So the primitive number that you want to add, so it's going to be the current primitive, which is the one we run over right now, which is this. Let's copy it. and the point number is going to be the for each loop current point, like that. Close it down, and that's it. So you will see now we have basically created exactly the same geometry as we have inside here. So see, even every point of it is exactly the same, which is very important. So these values are that actually returns the arrays are very nice, because they're actually going to return our points in correct order. Because I'm actually going to show what can actually happen if we create it in different ways. So we have basically created exactly the same geometry in our wrangle as we did it inside our main geometry. But now let's actually get our UVs back, and let's actually get our also some of these maybe geometry groups also. So let's get onto it. And before we continue, let's take a look at the example where it's actually not correctly created our polygon. So the setup is very similar, only here we work with a single polygon. So let's take a look at it. So we get the number of points for our polygon. Since it's a 1, we do not need to loop over the number of primitives, it's just one primitive. So in here we create our points, and up until this point everything is exactly the same as we did inside here. So you see the point number is exactly the same, 0, 1, 3, 2. It's the same one. But in here we also, at the same loop, we also add our vertices, and our vertices we add by the order of these, and by the order that we create these points. So if you think about it, for every loop we create a first 0, 1, 2, 3, but our vertices should be created by 0, 1, 3, 2, because think about it, for every loop we go through here, then we create a 1, and then in this loop we go to the 1, we create a point, and at the same time we also create our vertex. So but that's why it's not correctly created. So we say it's in here, and then we go to the 3. So this is exactly what causes our wrong polygon creation. So if you take a look at this, I added to the array, it's basically 1, 2, 0, 1, 2, 3. So the correctly would be for us to get our array from our prim points function. You see this array looks a lot better, 0, 1, 3, 2. So in this order we also going to create our vertices, just like in this wrangle. So from 0, then 1, 3, and 2 point, like that. So this is just some of the things to look out for if you're getting any errors when you create a polygon. So it's most likely the incorrect vertex order creation. So, and now let's get back to our main geometry. So in here we get our array of prim points. We want to use the similar function, but in here we want to get our primitive vertices. So let's just copy this and let's call it prim vertices, and the function is basically the same. It's called prim vertices, and setup is going to leave the same one. So the current, so we just want to get the same from the current primitive we are running over. So let's go for the, so where's this loop? Okay, this is where that's for each loop. We want to create another loop, and let's create our for each loop. Since it's an array, we also use again for each loop. So let's call it a prim vertex as a single value. So there's going to be int prim vertex and prim vertices as an array. So one thing to note that this prim vertices array contains the linear vertex references. So there are, let's take a look at the help file. So prim vertices VEX functions, you will see that it returns the linear vertex indices. So think of it as a global reference within the geometry to this vertex. So since these vertices, so let's take a look at any of these. So since for every polygon these vertex numbers repeat, there are way for us to get the global reference to this vertex, which is numbering, a sequential numbering for these vertices. That if you think of it as a point number, but for each vertex. That's why we have vertices is 11,104. So for every vertex there's a unique numbering within a global within the whole geometry, and then there's a local number within the polygon, which is 0, 1, 2, 3, or how many sides there are for every polygon. So think about it as that. So that will be considered as a linear vertex number. And with this for each loop, what we want to get is actually we want to convert these primitive vertices. Let's call it linear vertices. We want to convert these linear vertices to the vertices number of this primitive. So let's do it like that. So let's get the int value. Let's call it the vertex index equals. We want to use the vertex prim index. We want to give it the geometry, so it's going to be 1, and linear vertex numbers, which is going to be our linear vertex. And this value is going to be a lot smaller, because basically we get the second value from any of these primitives. So, and since these linear vertices are unique numbers, we can get the vertex ID for each primitive of this like that. So, and now what we want to do is get the position of these vertices. So let's do it like that. So let's get our vector. So let's get the UV position. That's going to be, we're going to get the vertex function, and in the vertex going to get the vertex attribute. So geometry is 1, attribute name that we want to get is UV, primitive number is the primitive that we run over, which is the current prim all the way up here, and then we have to give it the vertex number. So you have to be careful what actually it asks for. So in this time it asks for the vertices index. I call it a vertices index because it's basically a local within the primitive vertex numbering, and the linear vertex is going to be a global one. So at this time the vertex asks for the linear for the vertex index. So paste inside here like that. So now we have gotten our position from our geometry vertex attribute, UV attribute. So basically all of these values we have gotten for each one of them, and the only thing we have to do is set this vertex attribute. So set vertex attribute, and now I want to set it to our geometry 0. Let's name it also UV. Primitive number is going to be a current prim. The vertex number is, this time we want to also vertex index, and the value is going to be our UV position we just got, like that. And the mode is we don't need to use it, I just delete it since we do not have any other values, so since we are creating it. So let's take a look at it. So let's take a look at the UV. You can see we have copied our UVs, exactly the same UVs, to our new geometry created entirely from VEX. One thing we are missing is actually the groups of our geometry. So let's go ahead into the group and let's put it to the medium so that we have more primitive groups. You see by default there are already created a couple of groups for us to reference later. So let's actually recreate it with VEX, these groups. So let's go back to attribute triangle and let's go ahead to the parameter interface and let's get a string attribute for this. Let's get a string attribute for us, so we can actually let's call it prim groups. Copy, paste also label like that, and in these prim groups you're actually going to write in a simple expression function. Let's find it by prim group list, and this simple expression is going to give us all the list of all the primitive groups of the surface node. And remember, whenever you write these expression functions, you have to start with a backquote, and in it I'm going to copy it and inside it we just want to reference our geometry. So in this we can, just like in triangle, just reference the input of it. So 0, this would be 1, and that's it. Let me paste it again and press the enter. That's it. You can see now we have gotten our groups, prim group list, as a string that we can get inside VEX with this expression function. So let's go ahead and go to the VEX code and let's take a look at it. So let's convert this, since we want to loop over every group, we want to convert this string into the array. So let's go ahead here and let's call it a string, since it's going to be string array. Let's call it all groups. Make sure you have square brackets because it's an array. We want to split. We want to give it a string, and I'm just going to reference our channel prim groups we just created. We could create it as a variable, but since we're going to reference it only one time, I'm just going to write inside here. So because this CHS prim groups are going to return a string, and so this, and the separator is going to be just an empty string with the basically one space inside it. So it knows that we have to separate by the empty spaces between the words, and that's it. So let's print out the to take a look at whether it's correctly done it. Just quickly put in this and all groups, and this has to be in like that. So let's take a look at it. You can see we have correctly get an array of all of the groups inside it. Let's start by looping over this array. So we have to use a for each loop. Let's call it a group. Remember to write it as string. It's a string, and the array is going to be copy all groups like that. And what we want to do is actually get the group primitives of that group. So that would be pretty simple. So basically a primitive numbers is going to be also an array of all the primitive numbers that's inside this group. Let's call it a group prims, and it's going to be also an array. We have to use expand prim group. Expand prim group function, and then we have to give it geometry, and the group name is going to be for each which we are running over, which is the group string. Let's actually open up and add the help of this prim group in Houdini. Let's just paste inside here. You see it returns an array of primitive number corresponding to a group string. So we just give it a group name, and it's going to give an array of all the prims that are inside that group. Let's create our for each loop. So let's call it prim, and let's give it a group prims array like that. Oh, remember it's an int. Remember to typecast it. So now we want to use a couple of more functions. So we want to use a set prim group. Let's go ahead to the help and let's take a look at it. Set prim group function, which is going to add or remove primitives from group in a geometry. So obviously right here we do not have any groups in it. But if we use it, it's going to create it and add it these values that we want that we loop over. So let's do that. It's pretty simple. And since it's not returning anything, we can use just as a without any variable to it. So want to add to the 0. Let's call it the same as we got from our, basically the same name as our groups on main geometry. It's going to be group prim number is going to be our prim that we loop over, and its value is going to be 1. So since this array returns the values that are inside the group, we have to use 1 that's going to add it to that group, and 0 would be actually, I think 0 would be actually that it's removes it from. So let's take a look at the help, and there you go. Value 1 put the primitive in a group, and 0 to remove the primitive from the group. So yeah, you just have the 1 to add. So because this group it's different than the attribute. So if you take a look at our test geometry, the groups are basically 0 or 1 for every primitive. So it's either in a group with the 1 or 0 that it's not. So there's, you cannot have like a vector values or anything else. It's just that it's in or out of the group, 0 or 1. So, and if it's not, it's automatically going to get the value of 0. So that's that. Let's take a look at we actually should already have these groups being set up. There you go. You can see we have the same groups, and let's turn on the groups. You can see we have basically recreated the same groups: the face, the neck, the bottom of it, throat, and eyes. And one thing we actually can do is actually convert these groups to the attribute. That should be pretty simple. Set prim attribute, a 0, the name of it, let's call it a part. The primitive number is going to be a prim. The value of it is going to be the group name. So basically, we are, instead of the group name being its top value, we are creating a global, basically a attribute called the part, and paste these values as a group names as the values for each one of these primitives. And the mode we do not need, like that. So you see, this would be probably a more efficient way for us to get just in single way for us to get a reference to different parts of this geometry, if we do not have like a overlapping groups. And something like a blast, then we would, instead of referencing the eyes, we would referencing at part as a attribute equals, let's say, peak face, like that. So now we have written deleted the peak face, or let's invert the selection. So this will be the same as us for us to just write a peak face as a group or as attribute. So we have created it as a group or as attribute in a single line. And one last thing, I said that this set prim group doesn't return anything, but that's actually not true, because in help file, if you take a look at it, you can see there's an int in front of it, integer. So that means this function is going to actually return some sort of integer value. So that will probably be kind of basically a success check for it. So it will return something like 0 or -1, whether it successfully added or removed the primitive from the group of the geometry. So if that's important, if it's important for you to check these values, it's definitely something you can use and implement inside the code. But overall, I think that's it for this video. I think I did everything that I wanted to show in this video. We recreated the geometry from running over the one time over the detail inside one wrangle node. We got our groups, we even got our UVs, and obviously we could get many other attributes if you wanted to. So that's probably for the other videos. So that's it for this video. Thank you for watching, and take care.